Hello, this is Vidura. Here I will make a short video about some details of the BTG topic. It's referring to the Kacher coil, the modulation exactly. So here I have a Kacher coil. It's a quarter wave resonator, grounded on one end. My Kacher circuit has a current sense loop for the feedback, so it's automatically adjusted to the resonance always. I will show you why this is important. Here on the scope you can see it is 3.9 megahertz when attached to the earth ground. Now I will show you something. What I will do is simply approach my hand to the coil. Now see the response on the scope. These resonators are very sensitive to any object nearby which changes the capacitance, which changes its resonance frequency immediately. So the automatic frequency adjustment of this part of the high frequency resonator is, in my opinion, very important. It can be done manually, but you have to fix everything. Everything has to be in its place. And as I told you, if something approaches hand, or if you move the device from one place to another, you will change the resonance, certainly. Regarding the measurement, as you can see, I have simply put the scope probe nearby to the coil, which intercepts the scalar waves. Any metallic object nearby such a resonator will receive scalar waves, and EMF will be induced in this metal object. Something more about the voltage. We are here now, maybe voltage is not very high still, but you can see a small sparkle. It arcs some 2 or 3 millimeters at best. The voltage should ideally be higher. We should go around 3 kilovolts like this, or a little bit more even, as this is important for the output power of the device. There is something like a threshold which causes an ionization in the conductor. I have in this driver circuit, in this Kacher, attached integrated modulation device. It's a small MOSFET here which cuts and reconnects the oscillation circuit, the driver circuit, and I have now simply attached the signal generator, the function generator. Now with a square wave at 23% duty at 1.3 kilohertz. We will see this now on the scope, what happened. You can see it is it's very slow still. We will now test up to what frequency we can bring this coil specifically. As I have stated in the thread about BTG, the frequency, the frequency of the resonator of the Kacher is very important for the modulation, as slow coils of 1 megahertz or below will be much more difficult. We have a limit around 3 kilohertz for modulation. Now we will test up to what frequency this coil, which is nearly 4 megahertz, to which modulation it is capable. The idea is to bring the signal to a quarter of period of the secondary resonator or the granite coil or whatsoever. So I will now go up with the frequency. 2-3 kilohertz. We'll adjust this a little bit if we can get a better scope trace. I'm not now at 13 kilohertz already. Now the fish shape is visible. A clean triggering is very difficult with this thing. Here we go. Here we have the fish. Now what we need is to reduce still the time of the vibrations. So I will reduce the duty cycle of the signal generator. Sorry, I have to increase it as it is reversed. When the signal generator is on, then the Kacher shuts down. So it looks quite nice already. We see we'll zoom in a little bit more. We have now a duration of the pulses of about 15 microseconds. We will see if we can this bring down further. Here already we will affect the amplitude a little bit. If we go still shorter, the energy will be drastically reduced of the pulse trains. So I think something usable would be in this range, more or less, of 10 microseconds. I have now played around with the duty and with the adjustment of the function generator. Note that the duty cycle is inverse, that this is actually the off time of the Kacher. I could manage it to get to 24 kilohertz with this 3.9 megahertz Kacher. I'll show you on the scope. We have this nice dancing fish-shaped signal, which was shown often in Ruslan and Akula. We'll zoom in. Yeah, here you can see the carrier signal. And due to the modulation, there is always this nice pattern of a signal like this should be suitable for driving. Now the issue that we have is that the voltage is too low still. But this could be managed easy because I'm driving now from the battery, as eventually the interferences, well, my power supply don't like it. So I power it from the battery directly, passing through the meters. You can see I'm 12.5 volts, 13 volt almost. And the consumption is, we'll put the small one, consumption of 170, 180 milliamps. So we could go up with the voltage a good deal to 24 or maybe 30 volts without problems, and then we will get a good voltage, a good potential for the scalar emissions. So this should be suitable.